Welcome back everyone to another log for our SDL2 with C. So for this lesson, we're diving into something every great game needs, which is the multiple enemies and collision detection. So by the end of this log, you'll have a working system where your player or character can move around and avoid enemies and also even detect collisions between them. So all using clean modular code. So let's jump straight into the code and see how we can bring these enemies to life. For the project structure, inside the folder, we have the cmake_list.txt file, and we have an include folder, src folder, and assets folder. So inside the include folder, we have our header files, which are the animation, collision, enemy, and game header file. Inside the src folder, we have the animation.c, collision.c, enemy.c, game.c, main.c. Inside the assets folder, we have the character.png. So for the cmake_list.txt, so we have the cmake_list to create the executable file and link the libraries that we needed. And cmake is the building system that we're going to use. Here for the collision.header file or .h, we have a function prototype, we have the check_collision and clamped to window. So these are the function prototype inside the collision.header file. Now inside the collision.c file, so in line 8 up to 13, we have the check_collision function. So the collision detection function, we can use the SDL built-in, which is the SDL has intersection function. So in line 16 up to 29, we have the clamp to window. So this function will hold or clamp the camera to the window. So inside the enemy.h or the enemy header file, we have a enum, which is the enemy movement enum. So in line 13 up to 19, this enemy movement will have the different movement style for our enemies. So in line 22 up to 36, we have the enemy struck. In line 39 up to 42, we have our function prototypes. So for the enemy.c file, in line 9 up to 27, we have our enemy create or enemy_create. So this will allocate the memory for our new enemy and initialize all its properties. So it will going to have a dynamic allocation memory for our enemy, and then it will going to create an animation for this sprite sheet, and also it will going to set the position and movement type and randomize speed slightly for the variation. And also we're going to set the parameter used by the circular or the random movement. So in line 31, we have our enemy_update function. So it will going to call every frame to update the animation frame and move the enemy based on its movement type. In line 33, it keeps the sprite moving frame cycle. In line 36 up to 51, we have two types of enemy movement, which is the horizontal and the vertical. So in line 52 up to 63, we have the diagonal movement for the enemy. In line 71 up to 96, we will going to have the random movement for our enemy. In line 101 up to 104, we have the enemy_render function. So it will going to draw the current frame of the enemy at its position. So in line 108 up to 112, we have the enemy underscore destroy function. So it will going to free the resources or the animation memory and the enemy's track itself. So it will going to properly clean up to prevent the memory leaks. So for the animation header file, in line 11 up to 16, we have our direction enum. So this define an enumeration to represent which direction a character or player or object is facing or moving. So in line 19 up to 30, we have the animation struct. So this will hold all the data for one animation. So in line 33 up to 37, we have our function prototypes. Inside the animation.c file, in line 11 up to 25, we have the animation create. So it will going to create and initialize a new animation objects. And it will going to link the texture, set the frame size, number of frames, and speed. And it will going to return a pointer to the created animation structure. So in line 29 up to 45, we have the animation underscore update function. So which means that it will going to update which frame should be displayed based on the lapse time. So in line 52 up to 55, we have the animation underscore set underscore direction function. So this function will change the direction and movement state. So in line 60 up to 74, we have the animation underscore render function. It will going to draw the correct frame of the sprite sheet at the destination rectangle. Internally, it computes the correct source rectangle from. In line 77 up to 79, we have the animation underscore destroy. It will going to free the memory allocated for the animation struct. So in line 17 up to 31, we have the game structure or the game struct. So this is the main game state object. It holds all the data needed to run and render the game. So in line 34 up to 38, we have the function prototypes. So for the game.c file, in line 8 up to 29, we initialize the SDL, image, and the creation of window and renderer. In line 42 up to 47, we create the texture for the character and the enemy. So using the image underscore load texture, we're going to load the asset and create the texture from that asset. So in line 49 up to 52, we're going to have the character setup. So here in line 58 up to 64, we're going to have the enemy setup. So it will going to create 5 enemies, each with a unique movement type, and they will share the same texture but they have a different behaviors. Then srand will seed the random number generator for the speed and direction variation. So in line 66 and 67, we're going to enable the game running and game debug. So in line 71, we have our game handle events. And in line 73 up to 81, we have our event loop. In line 83 up to 85, we're going to get the keyboard state initialized at the moving to false and for the direction as well. And 87 up to 106, that is the keyboard press or the arrow keys when we press those keys. In 108, we use the clamp to window function, and 109, we use the animation set direction. In line 128 up to 154, we have our game underscore render function. So it will going to render the enemy and the player as well, or the character, and then we will going to draw the debug rectangles. And for the character, we have the blue box. For the enemy, we have the red box. And lastly, we are going to have a game underscore cleanup function, which in the line 156 up to 168. So this function will responsible for cleaning the resources that we used. Now for the main.c file, we are going to have our entry point function here. So here we initialize the game and we have our main game loop. And then if we exit from the game, we're going to clean up the resources that we used. Now we're going to compile or build our project using the CMake list.txt that we use. So here we're going to execute the CMake and create the executable file, and we're going to run that executable file. In this log, you'll learn how to implement AABB collision detection using a dedicated collision.c file. So we have also keeps the character or the player within the screen bounds with the clamped _to_ window function. And also we add the multiple enemies with simple patrol movement and animation. And lastly, we detect and respond to collision between the player or the character and each enemy. If you found this helpful, don't forget to like and subscribe. So thanks for watching, and we'll see you in the next one.